Hi, and welcome to another fantastic training session with Learning to Lean. Let's get started. Today we'll be covering Chapter 5 from the Certified Six Sigma Yellow Belt Handbook, Quality, Tools, and Six Sigma Metrics. In today's session, you will learn quality tools and Six Sigma metrics. Quality tools help you understand your problem. They're a method to communicate and collaborate. Quality tools helps us to visualize the data and make data-driven decisions. Now let's look at the 7 basic quality tools. Let's look at Pareto charts, cause and effect diagrams, flow charts, run charts, check sheets, scattered diagrams, and histograms. First, let's talk about the Pareto chart. This is handsome Vilfredo Pareto, an economist from Italy. He came up with the concept of the Pareto chart based on the concept that 80% of the land in Italy was owned by 20% of the people. The Pareto chart is otherwise known as the 80-20 rule. The chart helps us to visualize the items charted and separate the vital few from the trivial many. The Pareto chart shows the data arranged in descending order of frequency of occurrence, with the other category, if there is one, as the very last bar on the right side of the graph. The chart also contains a cumulative percentage line with a secondary y-axis. That is the red line that you see on the graph on the screen. In this chart, we can see that if we focused on the traffic issue by maybe finding another route to work or another means of transportation, we can help solve the issue of being late to work. This is a cause and effect diagram, also known as a fishbone or Ishikawa diagram. We use a fishbone as a structured brainstorming tool to help us find the root cause or causes to a problem. A traditional fishbone divides causes into several generic categories and has a measurable problem statement or cause as the head of the fish. You'd bring a group of people together to populate this in a brainstorming session by listing out all of the possible causes to the issue. At the end of the day, it doesn't really matter where you put the information on the fishbone in relation to the categories. The most important part is that you document the ideas. So don't get your head wrapped around the axle trying to figure out the right place to put the idea. Our next tool to discuss are flowcharts. A flowchart is a quality tool that helps people visualize a process in discrete steps arranged by the sequence of events. You can use a flowchart to document how things currently work. You can use it to create a new process and also for training. Here is a simple explanation of a flowchart versus a process map. First, let's make sure that we all know what a process is. A process is a set of interrelated activities that transforms inputs into outputs. A flow chart shows each step in the process. It has inputs, decisions, and outputs, and is used by teams to get a better understanding of process steps and sequence of operations. A process map shows each step in the process and contains additional information such as cost, setup time, cycle time, inventory, etc. A process map, just like a flowchart, has inputs, decisions, and outputs. It is also used by teams to get a better understanding of process steps and sequence of operations. With a process map, you can also use swim lane mapping. Here are the 7 steps to create a flowchart. First, determine the scope of the flowchart with boundaries. Remember, we're not trying to boil the ocean here. Pick a smaller sized process to work with first. Next, write down the steps in the process. Third, rearrange where required to reflect the current sequence of steps. Now we draw the flowchart. Walk through the process to test the flowchart. Step 6 is to identify opportunities for removal of redundancies, waste reduction, simplification, and standardization. And finally, communicate the flowchart to all stakeholders. Our next tool is a run chart. A run chart is used to identify patterns in process data. With a run chart, all of the individual observations are plotted in time sequence, and a horizontal reference line is drawn at the median. Why do we use a run chart? Well, we use them to detect trends, oscillation, mixtures, and clustering. In other words, we're looking for points of variation where a process might not be performing at the level of our expectations. Next up is a check sheet. You've probably used a check sheet in the past or even created one for yourself. Check sheets are used to observe or review a process, usually during the execution of a process. These sheets are pre-categorized to list potential outcomes to make it easier to gather and summarize the data at the end of your process or experiment. Here are the steps to creating a check sheet. First, identify and agree on the causes or conditions that need to be collected. Then decide who will collect the data, over what time period, and how the data will be collected. Pen and paper is just fine, or use something like an Excel spreadsheet. Create a check sheet that will work within the operation where it will be used. Next, conduct any training or briefing for an effective data collection. And finally, collect the data as designed to ensure consistency and accuracy of the information. Next up for our quality tools are scatter diagrams. We use a scatter diagram to explore the relationship between two sets of variables. This plot is a visual display of the correlation between the variables. The scatter diagram is created with the independent variables on the x-axis and the dependent variables on the y-axis. In this graph, we're looking to see how strong of a relationship there is based on the change of weight versus height. If there is a strong correlation, then a change in the weight will have a direct impact to the change in the height. Another graphical type of tool is a histogram. I think it's important to note that you don't always need Minitab or an expensive software to create these types of graphs. You can use Excel or even draw these graphs out manually if you need to. A histogram is a super easy tool to use to summarize continuous data collection from a process in a graphical format. The frequency of data occurrence is reflected as bars of various heights. The histogram is helpful for comparing before and after improvements. So, how do you create a histogram? The steps to create them include: identify the process parameter to be analyzed, collect the data to the required precision, divide the data into a number of intervals, and arrange the collected data by interval. Now draw a histogram based on the frequency of data falling at every interval. The final quality tool we will review is called a control chart. Have you ever had an EKG or maybe seen one? An EKG is actually a simple example of a control chart. We look at the EKG to understand anything that falls outside the normal range based on the person's age, health, etc. When we see something out of the ordinary, we ask, what changed to cause this abnormality? Control charts are used to monitor process stability and variability. There is always some level of variability. Just like monitoring our heart, there is a gentle ebb and flow or wave effect of the data that we gather. We call this common cause variation. This comes from people, equipment, method, material, and environment. The variability is measured and drawn as control limits on the chart. Control charts have control limits based on historical data. Control charts do not have spec limits. Spec limits are not based on historical data. They're numbers or targets provided by the customer. When looking at the control chart, we're looking for example of special causes. When those happen, the process tends to go out of control. Examples of special causes include a change in process, materials, operator skill, and an environmental factor like temperature or humidity. Again, when we see the data outside of our control limits or exhibit a pattern, we ask, what changed? To identify root cause and investigate. Now let's look at Six Sigma metrics. Metrics are a fantastic way to measure our performance against a target. The challenge is always trying to ensure that you're measuring and reviewing the metrics that directly impact your product or service and not fall into the trap of measuring everything and doing nothing. Metrics provide an understanding of our baseline, where we started, past and current performance, a measure against a goal, specification, or quote-unquote normal, and projections for the future. The first metric we will review is defects per unit, or DPU. The two data points you need to calculate DPU are total number of products produced in a time period and the total number of defects out of those products. You take the total number of defects and divide by the total number of products produced during a time period to get your DPU. We use DPU when the area under inspection is large in size or volume, like the number of defects on the roll of material. Now let's talk about defects per opportunity, or DPO. Let's say we have a pretend product, maybe a cell phone cover. We inspect for the following defects: scratches, dents, broken and bent. Given that information, we have 4 opportunities for defects. To calculate DPO, we take our calculated DPU from the previous slide and divide it by the total number of opportunities. Defects per million opportunities is easy, since we already understand what an opportunity is and we already calculated our defects per opportunity. We just take that and multiply by 1 million to get our defects per million opportunities, or DPMO. Rolled throughput yield, or RTY, helps us to calculate how likely it is to have a product go through all of the processes without a defect. We take the yield or efficiency for each step in our process and multiply them together to get our rolled throughput yield. For this example, we multiplied 0.994 times 0.987 times 0.951 times 0.990 to get 0.924. This means that the likelihood of having a product go all the way through all 4 processes and be defect-free is 92.4%. Let's talk sigma. Sigma is just a measurement. a sigma level is the quality level of the process. Six Sigma originated at Motorola and then further developed at General Electric to more of what we know of it today. So what is Six Sigma? Six Sigma is a methodology for problem solving. It's a common language for all of us to speak and understand. It's a mathematical expression or measurement. It's the standard deviation of a process around its mean. Six Sigma equals 3.4 defects per million opportunities. Six Sigma is the realization that 99% yield is not good enough. As you can see here, there are various sigma levels because, once again, it's just a measurement. A Six Sigma level has a yield of 99.9996%. Refer back to the rolled throughput yield calculation to understand how this can be achieved. Now let's talk cycle time. Cycle time is the time it takes for a process to be completed from start to end. As a yellow belt, you may have to measure wait time or queue time. This is the time that the material sits idle before the transformation is started. Lead time is the time it takes for the material to arrive from the time an order is placed at your supplier. Your customer may also ask you about your lead time for the product or service that you provide. Cost of poor quality, or COPQ, is the last metric that we will review. It's also referred as cost of quality, or COQ. COQ is the overall cost that includes both the cost of conformance and the cost of nonconformance. The cost of nonconformance is the sum of internal and external failure costs. An internal failure cost includes scrap, rework, repair, and retest. External failure costs include customer returns, replacement, investigation, and administration. The cost of conformance is the sum of the appraisal and prevention costs an organization incurs to ensure the products and services conform to specifications and customer requirements. COPQ and COQ are measured as a percent ratio compared to the cost of goods sold or cost of goods manufactured. So just as a review, in today's session, you learned the 7 quality tools and all about Six Sigma metrics. Thanks for joining me in today's session. Don't forget to subscribe to our YouTube channel so you're the first to know about videos as they are released. You can also find us online at www.learningtolean.training. Thanks and have a great day.